So I welcome you all on behalf of the management of CDP Networks. So before we start these sessions, I will just give you some brief information of what to expect in this training. So this training will happen for this week for 5 days, and these sessions are free sessions. So generally our training are divided into two parts. So we have free sessions and we have some paid sessions. So around 30 to 40% syllabus will be covered this week in the 5 sessions which you will be having, and these sessions are free sessions. And those participants who have sat for our free sessions and we have their info by the end of this week, we generally give them around discount of 50% to attend our paid session. So the paid session for this batch will be announced by the end of this week. The date and the information will be announced in the group. It will be for 7,000 rupees. And in that, most of the syllabus which is remaining out of this 40 or 30% will be covered in that part. And of course, we take information and collect data from the candidate that when exactly they want these trainings to happen, the date, the time. So it will be as per your convenience. So now, I will like to ask our trainer to just give you some information and introduce himself about what he'll be covering in these 5 sessions this week and what we can expect in the rest of the sessions which he'll be covering after that. So over to our trainer.
Thanks for joining this course. I want to sharing some documents. Um, Please allow me. Uh, Today, we are just sitting for one certification exam. This is a topmost network provider, Juniper. Juniper, like Cisco, Juniper also provide a different category certification like service provider, enterprise, security, data center, cloud, in various category. So this course is only focusing JNCI Juno. So this is very basic. That means it's an associate course. Juniper divided their certification in 4 categories. If you just show the Juniper website, just type here Juniper certification. I just close this one. Just type here Juniper certification, Juniper certification. Firstly, I just focusing the certification, different type of certification category, and which one we actually focus for this course. Just go certification. Juniper Networks. And this is the page of certification. So there are you see there are different tracks. Tracks is automation, cloud, data center, design, enterprise, routing and switching, mixed AI. That is basically wireless, and security, and last one is service provider routing and switching. So and every track divided in 4 parts, that is associate level, specialist level, professional level, and expert level. If you just compare with Cisco, Cisco have 3 part or 3 level. That is, one is associate level, second one is professional level, and last one is expert level. But Juniper divided this in 4 parts actually. So we're just discussing JNCI Junos. JNCI Junos, this certification. This certification is a prerequisite for enterprise routing switching, also the service provider routing and switching. If you go the enterprise, just JNCI Junos. Junos Associate JNCI Junos, this is the course name, and course code will be JN0104. JN0104. Where is the code? Um, oh, this is the new announcement. They are already this running is JN0104, but in January 29 and 2024 there will be change. Okay, there will be change, so that will be JN0105 actually. Okay, so this is your basically the total course outline. There are divided in 6 to 7 parts. The first one is just fundamental, and the second one is just operating system architecture, and the traffic, how to control or how to handle traffic in Juniper devices, then CLI interface, basic configuration, that means monitoring and maintenance. This will focus also routing fundamentals. In routing fundamentals, you will learn static routing and voice pipe routing here. Because this is a very basic course. For that, there is only cover static routing and voice pipe routing. But if you go the next, that means JNCIS, that means specialist, then this syllabus will be covered in deeply in routing fundamentals, yeah, in different routing protocol covered. And routing policy and firewall filters. So also these two topics is very important. If you just handle one organization, it may be enterprise, it may be service provider, you have to maintain routing protocol, you have to maintain the policies are, so this is very important. So this is the this is the exam objectives, or you can say that this is the outline or topics which will cover under this course. Okay. So, and another opportunity Juniper provide. Juniper have their online platform. If you just register yourself, you will get. If you participate in, that means their dummy exam. That is dummy exam is called actually called. Bhavsar assessment test. Okay, if you just complete the JNCI Junos, after completing this course, just I will help you to participate, how to participate Bhavsar assessment test. If you pass the Bhavsar assessment test, you will get 75% discount from that respective course. So this course just around $200, but if you get the Bhavsar assessment test, that means you will get the voucher. So if you get this voucher, you will just need $50 per exam. This is valid for every associate course. They will provide multiple associate course. Just see associate level, specialist level, professional level, and expert level. So in associate level, see how many courses they offer. I will do here Junos Associate JNCI Junos this course, but you have to score 70% in assessment exam. Then you will get 75% discount. Only $50 for vendor exam. Need only $50. Only $50. So this is actually I think big opportunity which provide Juniper for education. Okay. So just I go to the syllabus. So who is one will cover free, and who is one actually cover in paid. So you will just already get this outline or syllabus in your group. So basically this outline is just copied from here. So you can follow, you can also follow this outline also, no issue. Okay. So in free option, or in free classes, you will learn network fundamentals. This is very basic. That is basically it's equivalent to CCNA knowledge. Just how network is communicating, how one user communicating internet from one source to destination, how it's happen. So this is the very basic part, that's including basically IPv4, IPv6, subnetting. Any question? This is syllabus. Okay, okay. I just open here. Wait, this is basically same. Mm. And this is already shared with you. Okay. This is the network fundamental parts. In network fundamental parts, it is the very basic concept. Just if I just starting, could I start today? I will cover the networking fundamentals, right? In today's class. Hello. Yes. Okay. Thank you. So this is a very basic concept for internet for network. Okay. So the first one, just say here, this is the first one, the collision domains and broadcast domains. So what is the collision domain? What is the broadcast domain? Just if you see or you already here, I think the device's name, hub, the devices is Swiss. There are different type of devices in our network. Okay, some devices use for just transmit all devices actually use for transmit traffic basically one source to another destination, but there are different types of devices and they maintain a different role basically. Okay, so in layer 2 perspective, if you just I recall the OSI layer, layer 1 to layer 7, if I consider the OSI layer, that means layer 1 and layer 2, just consider the layer 2. In layer 2, there we are using switch. This is called the device is called the switch. Switch just making forwarding decision based on MAC table, based on MAC table. So if every port of a switch and making the collision domains, and what is the broadcast domain? Broadcast domain is just consider you are the listener and I'm the trainer. I am saying something, you are hearing. Okay, so I am sending some message or getting this message, all the participant. This is called the broadcast. Okay, just consider this is your switch. It's maybe layer 2, it's maybe layer 3. Multiple end devices connected in switch. It's maybe laptop, it's maybe printer, it's maybe server or desktop. Okay, it's maybe wireless or it's maybe wired. So, okay, just think this switch is just power on, three devices connected here. So I want to send one packet from 1 to 3 and device from 1 and device to and device 3. So this source device di- don't know where is the device 3. They don't know. They ask, firstly, they ask. Firstly, they ask, just consider this packet is coming in switch in incoming port. In Swiss, they just learning the frame from incoming port and populate their MAC table. But they the port, didn't learn the device 3 MAC address. So what will happen? Happen is they said all the all the port connected with switch except incoming port. So this scenario is called the broadcast. So there happened broadcast. This is called the broadcast domain. So in after learning MAC, which is connected in your switch, they populate the MAC table. If they send second time, if they send the packet from device 1 to 3, they just match the MAC table and forwarding one port to another port. Okay, so this is very basic function of switch. So if you consider one port, switch one port making the collisions, and if you consider this device is hub, one device is communicating to another device. If device 2 want to communicate with 3 or 1, that will not happen. That will make the collision. If switch, this will happen. No problem. Port switch, we consider every port have collision domain, and broadcast domain means, or if I consider one subnet, this subnet, multiple devices connected, one subnet contain one broadcast domain. One subnet contain one broadcast domain. Just consider one subnet, very simple, 192.168.1.0/24. This is your subnet. This is IPv4 class C subnet. So this is the network address. This network have one broadcast. This network have one broadcast IP. What is the broadcast IP of this network? Anyone? 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 What is the broadcast IP of this subnet? No. This network is 1.0. So how? 255. Network is 1.0. So how in third octet 255? Yes, perfect. Perfect. 1.255. Exactly. 1.255. Because this is the 24 bit in network. Okay. So that's why this will fix. This portion will be fixed. Okay. So our broadcast IP will be 255. This broadcast IP basically responsible for detecting the this broadcast IP basically forward the broadcast message to every host except incoming host or incoming port. Okay, so this is the collision domain and the broadcast domain which happened in layer 2 perspective, which happened in layer 2 perspective in OSI layer. So just then function of routers and switches. So what is the function of routers? Router is a network device, number one. And what is the function? You can use router as a internet gateway device. Just consider your home. One Wi-Fi router is in your home for Wi-Fi connectivity. Okay. This is the ISP cloud. One cable is connected in your router and you will get Wi-Fi through through wireless. Through wireless. So what is the function? This router is act as a gateway device to connect the internet. So this is the very basic function. And another function is in router we'll configure different routing protocol. You can filter any traffic. You can filter any traffic by using the router. But in filtering concept, they are provide the separate device. This is called the security device. Basically, if you just consider Juniper will provide the SRX device for security perspective. Okay, but in router, you will make basic firewalling functions. Okay, so router, you can act this router as a gateway router. Router will perform different routing protocols. Different routing protocols basically router basically choose the best path. Basically choose the best path. If multiple service provider is connected in your router, router will decide what will be the best. Service provider 1 is best or service provider 2 is best. This will basically happen in router, and router will make the decision. Okay, so router, it's a networking device, number one. Number two, It's used to make or choose the best route or best path. Number three, it will be used for filtering also. So this is the function of routers, and another device we'll use in our network, that is switches. So switch, what is the function of switch? Switch, just you consider this is your LAN network. One switch is connected here. Basically, we use switch to connect different end device. It may be laptop, it may be desktop, it may be server, it may be printer. If you consider wire, if you consider wire, if you consider wireless, just you connect one AP. AP means access point. One AP is connected here, and this AP connect your mobile station through the wireless. This is your mobile station. So this switch, what is the role of this switch? To connect end device. To connect end device. And this switch, how to make the decision. How to make the decision. Like one user is connected through the wireless, and their gateway is this router. Okay. So if I send the packet in the internet, so this just getting Swiss just getting packet in incoming port, and Swiss take decision based on their MAC table, media access control MAC table. Based on MAC table, they decide which will be the forwarding port. So this is just, if I considered this PC just accessing the internet, this will be the, this is a gateway router. That's why this interface will be the forwarding interface. So if I sending any packet to this server, this one server is connected here, this server. So this packet is just incoming port will be this, and outgoing port is this. So this will making based on forwarding table, based on MAC table. So this is the function of switches. Basically, connect multiple end devices in our LAN. In our LAN. This is the basic functions. So Ethernet networks, if you see our enterprise network, service provider network, or home network, every network have Ethernet connection. If you see the router, every maximum router have the Ethernet port. Ethernet, you can if I go just earlier, just Ethernet first Ethernet, that capacity was 10 Mbps. Then coming first Ethernet coming with 100 Mbps. Then gigabit Ethernet coming with 1000 Mbps port. And now we see 400 Gbps, 10 Gbps, 140 Gbps, 100 Gbps port, 400 Gbps port. Everything is Ethernet. So our all traffic is passing through the Ethernet networks. And this is the history of Ethernet. Okay. So what is the layer 2 addressing, including address resolution? What is the layer 2 addressing? Layer 2 addressing is called the MAC address basically. Okay. That is built up 48-bit, that is basically expressed in hexadecimal format. Okay, this is also this I just go a lab, I just making a lab to making better understanding. Just for in your class, I will use EVNG. This for EVNG, it will provide the correct image, which image we will use in our entire course. I just show. Um, then just go to browser. 192 is the ng environment. Just making one JNCIA Junos JNOS. This is December 23. Okay, just taking a node VMX Juniper. This is the Juniper router basically. This is the default setting. Taking one switches for better understanding. I will take basically Cisco. Later we use Juniper switches and take one PC here, VPC. Okay, you can choose two PC here. No issue. So just take this PC 0. Zero point one. Just take here one submit here like 192.168.1.0/24. Save this one. This is subnet. Options. Yes. Zero, three, colon, A, double colon. Yes, recording is running. Yes, VPC. So we are discussing layer 2 addressing. This is sys. This is basically PC. Set PC name VPC3 and this PC name VPC4 and this IP 192.168.1.0. 3/24, and gateway is considered gateway is 1. Gateway is 1. This PCIP, this IPv4 IP, and the 4 for PC4. Check, show, make, stable. See here, or just layer 2 addressing. So layer 2 addressing, layer 2 address is this address is called the layer 2 address. This address is called the layer 2 address. This is also called the MAC address. Okay, layer 2 address is or MAC address is totally 48 bit, totally 48 bit, and this is expressed in hexadecimal format. Okay, so if if this is total 48, that means there is total character is total character is how many here? 12. So MAC address total is 48 divided by 12 is equal to 4. That means this is hexadecimal bit. So every character, every digit is equal to this binary 4 bit. Binary 4 bit. So total is 48 bit. So this is the layer 2 addressing. This is called the layer 2 addressing. So and layer 3 or IP addressing, this is called the layer 3 addressing. Layer 3 addressing, this is the IP address. This is basically IPv4 address. You know the IPv4 address is a total 32 bit and expressed in decimal format, and separator is dot, and range will be there have 4 field. Every field have range is 0 to 255, 0 to 255, 0 to 255, and 0 to 255. And the /24 is the total number of network bit for this subnet. For this subnet. So just go to your router, then log in this router. Default 123. Just showing you the this. I will discuss detail in later classes. This is the very basic configuration of Juniper devices. So for better understanding, I will just making this happen. You have to delete m0 m0 set. Just go to your lab, and then this is your gateway interface G0/0/0 set interface GE dash 0/0/0 unit 0. I will discuss later why I use unit 0. Family init address is the gateway address. Gateway address is 1.1. Gateway address 1.1/24. So just make the commit and take one captcha in gigabit Ethernet 0/0 interface. Just I'm making this to cover the address resolution. What is the address resolution? Okay. So see here. This is basically what is actually happened in network. What is actually happened between router and switch, or PC to your router. Okay, just nothing happened. Just loop back testing and some STP related communication is happened with choice. If I send one packet, just go to PC3, then sending one packet. This is ICMP packet. This make happen. I getting the gateway. So what is the process? Just see here. First one, this is ARP request. This is ARP request. So this request is broadcast. This request is broadcast. If you see the layer 2 frame here, this is ARP request, this ARP request, and see the layer 2 header. See the layer 2 header. In layer 2 header, this is the source MAC address and this is the destination MAC address. This is the destination MAC address. So what is the meaning of this address? In layer 2, this address is called the broadcast address. Because I actually don't know, PC3 don't know where is connected their gateway. Where is connected their gateway. That's why the making the ARP request through the broadcast. This frame thus just taking the incoming interface and sending every connected port of that switches. Okay, so this is the source. Just go here. This is the PC3. In PC3 is connected. Just PC3 is connected. Port is gig 0 by 1. So gig 0 by 1. In gig 0 by 1, just see here. Just see here, gig 0 by 1. What is the MAC address? This is your MAC address. Last part is 6803. If you see the packet capture 6803, this is your, see here, 6803. This is your source. This is your source. Packet sending from PC3 to your router. So if this make happen or getting ping, first you have to complete ARP resolution. You have to complete ARP resolution because you don't know. You would not communicate with the gateway. This is the first item. This is the first packet. So this is the broadcast and this is called basically ARP resolution, address resolution protocol. In address resolution protocol, see here, in address resolution protocol, see here, packet is coming from 1.1, this, and tail 1.3. 1.3 is your PC. Your PC tail 192.168.1.1. Where is 192.168.1.1? So this is the broadcast. Just getting response from this MAC. Getting response from this MAC. This MAC is connected. IP is 192.168.1.1. This request just go to the second packet. This request is, this is your source MAC. This is your destination MAC. So this is the ARP resolution in layer 2. This is called the ARP resolution in layer 2. Okay. So is it clear, guys? Layer 2 addressing and address resolution, is it clear? Hello? Are you hearing
Yes,
me?
sir.
Yes? Okay. Then layer 3. Layer 3 is called basically IP addressing. Basically IP addressing. IP addressing will be in two versions. That is, one is IPv4 and another one is IPv6. In IPv4, total number of bit is 32, and IPv6 total number bit is how many? 1 to 8. If I write any address in IPv4 and IPv6, just see here, I write here one address in IPv4 192.168.1.0/24, and in IPv6 2023:A:/64. This is the writing convention in IPv4 and IPv6. Basically, we'll not discuss a detail in IPv4 subnetting, PLSM, or anything else. Just I consider you will know better in IP addresses. If you have any confusion in IP addresses like subnetting, PLSM, so in that case, I will make a separate class. Okay, just 1 minute. Okay. Guys, need any separate class for IP understanding? That is IPv4 address and IPv6 address. Could you respond? If need, basically, we'll do IPv4 address, subnetting, BLSM, or IPv6 details concept. Do you need this one? In JNCI, just we consider you have knowledge regarding IPv4 and IPv6 address, then just considering this, we will go through the course. If need this one, basically, okay. That means you will know better IPv4 and IPv6 address. Thanks. Thank you. So just layer 3, the layer 3 means basically IP address, IPv4 or IPv6, maybe IPv4, IPv6. If you consider the IPv4 address, this is have the subnet mask. And if you consider IPv6, you can just say prefix and prefix length. First option is prefix, and second option is prefix length. Just you just go the lab and see the addresses. Addresses is two part. One part is the prefix, and another part is prefix length. Similarly, this is the prefix, and another is prefix length. So you can divide as like this. So just configure the IP addresses here. This is your IP address with subnet mask. If you see the packet, just checking one. This is the source IP address, and this is your this is your source IP address. This is the PC, and this is the destination IP address. This is the gateway router. This is the ICMP packet. ICMP packet basically in two type. One is request and another one is reply. PC3 is sending the request to a router, and router is basically reply the host or reply the PC. This is the two-way communication in ICMP. Okay. So just subnetting and supernetting. Subnetting is just if you just consider notepad better subnetting. So you just consider you have a LAN. This is your LAN. There is multiple department is connected with the switches, and consider you have two department. One is Acer and another one is IT. So Acer is or Acer have 10 or 5 persons or 5 PC. IT have maybe 10 PC. So you need the IP addresses for Acer PC and IT people PC. So what will be the planning of IP addresses? Which IP address will be assigned for Acer and which IP address will be assigned for IT people? Okay, you can consider this subnet just here 192.168.1.0/24. This is your reference network. This is your reference, like you consider this is your reference network. For you You see here, you need two network. You need one network for Acer, another network for IT. You need two network. So just if you make two network from this subnet, this is very easy. Just converted these IP addresses to just this is last one number is called the prefix length. Also, you can call this number is the network bit. So your total bit is 32. Out of this, 24 is network bit. So here, a bit is in host. So you can write this one like 192.168.1 dot. This is your host bit. This is your host bit. So you need two network. You need two network. So for two network, you can take one bit. You can take one bit. This bit is called the subnetting bit. This bit is called the subnetting bit. So if you take the one bit, you will get 2 power 1 equal to 2. Two combination. You will get two combination. Just right here. In binary, there is, you can set here 0 or you can set here 1. This is the two combination. If you write here network number, host bit will be 0. So first combination in last octet, all is 0. That means network will be network will be 1.0, and this prefix length or network bit will be, in previous I have 24 bit in network. So 1 is added. So 24 plus 1, this is 25. This is first one. And second one, this is 1. That means 2 power 0, 2 power 1, 2 power 2, 2 power 3. This is called the 2 power 7. That is equal to 1 to 8. 1.128 slash 25. So this is your first subnet and this is your second subnet. You can give this subnet for Acer and this subnet for IT. This is called the subnetting. So what will be the supernetting? What will be the supernetting? It's very simple. Just take some random addresses. You just have multiple branches. One is like this subnet, another one is 2, another one is 3. Like this is 2 and like this is 3. These are three subnet. This is individual subnet. If you just compact it or convert it into one, three subnet is converted into one. That is called the supernet. If you just converting three subnet or multiple subnet converting in one subnet, that is called the supernetting. So if you make the supernetting from these three addresses, three network addresses, what will be the process? Process will be, so just consider here all are in 24 bit. All are in 24 bit. So if you just see here, this is 1, this is 2, and this is 3. So there have some tricks. There have some tricks. Tricks will be, if you have 4 bit, like 4 bit in third octet. In third octet, just consider here, just copy. This is your host bit, consider, and this here all are in network bit, all are in network bit, all are in network bit. That is this is basically network bit, and this is a network bit. So how many, you have to take how many bits to making the four networks? For this way, you can making the supernetting, and I will show you another easy way. Just making this address Where is change in third octet? Third octet, you have getting the changes. Third octet, just you getting the value 1. Just converting this value in binary format. Converting this value in binary format. So what is the equivalent of 1? Just I make here. How many bits here? Every octet have 8 bits. So if you make 1, this will be 1. This will be 1. So this totally binary format. This will convert, if I convert this binary format in decimal, that will return 1. That will return 1. So similarly, just converting left of this one, just 2. What is the binary of 2? 2 is the decimal value. What is the binary? Binary, that is, this is 1 and that will be 0. 3 and 3 value is this one. So making the AND operation. Making the AND operation of this. So just making the AND operation 192, that will return the 192, 168, all are 168, that will also return the 168. But making the AND operation here, 101. What will back in AND operation? Anyone? 101. What will back? What number will back? Anyone? In AND operation, if every value is 1, that will return 1 only. Okay, so 101, that will return basically 0. So last second 011, 011, that will return also 0. 011, 0. And left of this, all are 0. So I will just see here, all are 0. So if I convert it in decimal value, if I convert it in decimal value, this value is equal to 0. And what will be the prefix or what will be the network bit? Network bit number. So consider here, this portion is common, right? In every 3 network, this portion is common, right? Only changes last 2 bit. Only changes last 2 bit. So what is the common bit? The number of common bit is 6. The number of common bit is 6. And there is 8 bit. There is 8 bit. 8 plus 8, 16. 16 plus 6. How many? 22. This is called the supernetting address of 3 subnet. Guys, clear? What is the subnetting? What is the supernetting? And how to make this subnetting, supernetting? This is a very short way, basically. Any question? Are you getting this? Hello?
Yes, sir.
Okay. So this is the subnetting and supernetting. Decimal to binary conversion. How to convert the decimal number to binary or binary to decimal? There is some easy way. Just see here. I think you also know. Two, I use here 2p or for power, basically. 2 power 7, 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power. Okay. 2 power 7, 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, and last one is 2 power 0. See here, 0 starting is 0 and ending is 7. So how many bit? Starting is 0, ending is 7. How many bits? 7 bits or 8 bits? 7 or 8? Guys? Hello? 8. Perfect. Because starting with 0. So total is 8 bit. In IPv4, every octet have 8 bits. Every octet have 8 bits. Okay. So 2 power 7, what is the value? 2 power 7. Just go to, it's very simple. 2 power 7 is equal to 1 to 8. It's, it's a mathematical calculation basically. 1 to 8. So what is the value of 2 power 6? 64. And what is the value of 2 power 5? 32. Yes, perfect. Perfect. So 32 2 power 4 is 16. This is the very basic. Okay. 2 power 2 equal 4 and 2 power 1 equal to 2 and 2 power 0 equal to 1. That is a to the power 0 equal to 1. That's why 2 power 0 equal to 1. This is the decimal value equivalent to this power value. Okay. If just consider here this value, just consider this value. What is the decimal value? 0, 0. Just consider here 0, 0, 0, 0, 0, 0, 0, 0. So what will be the calculation? If I place 0, this will not take. If I place here 1, this number will take. So just consider, if I place here 1, what will be the decimal value of this? Anyone? What is the decimal value? If I consider 1 out of 8, guys, 16. Perfect. 16. This is the number 16. This is called 16. If I change something, like another example, just change here this one. Or what is the value? Here, this is 1 and this is 1. What is the value here? 80. That means 64 plus 16. That is equal to 80. Perfect. This is the conversion. This table basically help to convert binary to decimal. This decimal to binary conversion. In same way, you can convert decimal to binary. You can convert decimal to binary in the same way. If you just taking one number, just random number, say one random number, say one decimal, say one random decimal number, anyone, but this have to range in 0 to 255, 0 to 255, 112. Okay, perfect. 112. So what is the binary value? What is the binary value? So 112, consider here 128. If I consider here 1, that is bigger. That is bigger. So not take this one. That make this 0. This is 64 and this is 112. This is smaller than your given value. So you take 1. So out of 112, you take 64. Then consider later 64. If you take here 1, 64 plus 32. So take the calculator and sum 64 plus 32 is equal to 96. That is lower than your given value. So you can take this one. Okay. Then go to next. Next is 16. If you take this one, your 64 plus 32 is 96 plus 16 equal to 112. Perfect. 112. That means 112 done. So go left is 0. just making others 0. So this is basically 112. Perfect. Is it easy or hard? It's a very easy task, right? Guys, is it hard or easy? Please, guys, please respond. Otherwise, I can't measure. You understand this or not? Yes, okay. So this is the conversion, decimal to binary conversion or binary to decimal conversion. You can do this very easily. Longest mass routing. Longest mass routing. What is this one? Longest mass routing. Just consider here. This is your gateway router. This is your gateway router. Just consider this is your gateway router. You will, this gateway router have multiple route in their routing table. Multiple route in their routing table. Maybe this routing table maybe like 192.168.0.0/16 and their gateway interface is z 0 by 0 by 0. Just consider another entry. Consider here 24 and this interface is 1. Another entry like you consider here 32 27. This interface is 2 and another one like consider here 28 and value is consider here 0. Also consider here 0 28. Okay, so another one is for 5 and this is 0.0.0.0/0. Okay, I am asking, this is the route table of this router. I am asking just number one, send packet to basically router take decision based on destination address, not the source. Okay, so I ask router to send packet to the destination will be 192.168 192.168.167. I place here 167 1.1. So which interface router will take to forward this packet? Guys, which interface will choose the router to forward this packet? The destination is this one. Which one? Anyone? Anyone? Router, just look up the routing table. 5. Yes, perfect. Interface 5. Router, look up the route table. 192.167. So this is not the 192.167. So they have default route. This default route have all IPv4 routes, matching the all route IPv4 route. So this interface will be 5. If second question, if I sending packet number 2, if I sending packet 168 1.1, what will be the exit interface? Packet is destined to 1.1. 192.168.1.1. Router will choose which interface as a gateway. Same confusion, right? One is called same, that means 5. So one answer, number one, say 5. Number two, say 001. Anyone? Anyone? Anyone choose any other option? These both are incorrect. These both are incorrect. Because this is 00. This is address is 0 to up to 255. 0 to 255. And these address have all 0 to 255 here, and here is 0 to 255. Because this is slash 16. This is slash 16. That means interface will be this one. If packet sent to number 3, this is the last one. See here, number 3, packet is sent to 0.1. So what will be the exit interface? What will be the exit interface for 0.1? Guys, this is the very basic. Here you just consider longest mass routing, longest mass prefix length. I several times says this one is the prefix length and this one is the prefix length. Longest prefix length will mass fast. So answer your question. So answer your question, guys. 0.1, this IP in this subnet, right or wrong? This IP include in this subnet, right or wrong? Right or wrong? Right? Obviously right, guys. 0 dot, that means this range is 0 to 255. This octet range is 0 to 255 because this is 16. This IP include in this subnet. Okay. So go to second subnet 0.0. So 0.1. This is the first valid IP of this network. This IP also in this subnet. Correct. Go the third subnet 0.1. This IP also include this subnet also. Here range is 0 to 31 because this is /27. If I goes to this subnet 0.0/28, this range is 0 to last octet, 0 to all mentioned interfaces. Perfect, perfect. All mentioned interfaces. This IP have in all mentioned interfaces. But routing choose which one? Which one? Longest prefix length. Longest means highest. 28 is the highest here, right? 28 is highest here. So exit interface will be kick 0/0/2. Perfect. Router will take decision based on longest prefix mass. So this is your topics here, longest mass routing. This is called the longest mass routing. And last, oh, no, not last second topics, class of service. Class of service. Basically, class of service is used, just consider here. This is your just PC. If you consider one port is connected with your IP phone in office IP phone. IP phone. IP phone is used for sending voice traffic. Sending voice traffic. Okay. And another or your PC is connected behind this IP phone. So this PC is used for only data traffic. This PC is used for only data traffic, and this IP phone used for voice traffic. So voice traffic is very sensitive, very sensitive. It's very latency sensitive. Okay. So I have to prioritize the voice traffic. So how to do this? Class of service. How to do this? Class of service. By using the class of service, we can enforce the voice traffic based on switch or based on router. And data traffic will just place the normal class of services. In Juniper operating system, there have default four class of services: express forwarding, expedient forwarding, network control, and base default. Basically, base default is the regular class of service for every packet. It's maybe data packet, it's maybe voice packet. If you emphasize the voice packet or video packet, you have to configure class of service. You can convert it expedient forwarding or assured forwarding. Okay. So this is the concept of class of service. So next is the last one, your last topics: connection oriented versus connection-less protocols. You already know connection. Which protocol is connection oriented? Which protocol is connection oriented? TCP, right? TCP. Yes, TCP. And which protocol is connection-less protocol? Connection-less UDP. Why? Why? Just I take example. You can define your traffic in two categories. One will be voice, another will be data traffic. One is voice traffic, another is data traffic. In voice traffic, you just consider in Zoom platform, I am just sending some voice through the internet. You are just listening the voice. If any interruption happened in my network or your network, you will miss something. You will not recover this. You will not recover this. But in data traffic, if you consider the data traffic, I just place here some website. I just place here some website. If my internet connection is just interrupt for some seconds, they will just waiting for getting the next packet, waiting for getting the next packet. They will not close immediately. In this scenario, basically, they will make the every make the sequence of every packet. If one packet is missing, they are waiting for that packet. If that packet is coming, then sending to another packet. This is the sequential order. This is happened in sequential order. And if you send something on the destination also have record on that packet. Record on that packet. So if like this page is coming, this page may be 1 Mbps. So in data, if you consider this is 1 Mbps data. So there have packet header and the payload. So for a smooth connection, this 1 MB packet will divide it in multiple packet. Basically, multiple packet. It's maybe 8 packet, it's maybe 16 packet. They're just sending one packet, then sending another packet. If any packet missing, they are just waiting for next packet. If every consider you just get all 16 packets. You will see this space. You will see this space. So this happened, and they have some track, they have some sequence in both in source and destination. This is called the connection oriented, and this is happened in TCP, because see here, I use here HTTPS. See, if I copy this one, you see the first beginning is, this is HTTPS. So HTTPS, this is called the TCP packet. TCP packet. Okay. And voice video is called the UDP packet. UDP packet, you can't recover it. This is not connection oriented. And TCP packet, you can recover it. This is because this is connection oriented. So that is the difference basically. Connection oriented and connectionless protocols. So I guess I have completed today's topics. If you have any question regarding our today's topics, feel free to ask me. I will repeat if you need anything or any topics. This is open for all. If you have no question, I will hand over to CDP Networks. CDP Networks, please continue. I have completed today's session. Are you hear me? Anyone from CDP? CDP Networks? Guys, what's your response from today's class? Is it okay for you? Have you understand everything? Next class, basically, we will work with Juniper router and Juniper devices. Today is very basic class for network fundamental. Data addressing, topic once. Okay, I repeat it. In layer 2 addressing, basically, we call this one MAC address, media access control. This is basically built in total 48 bit. So this 48 bit is basically coming from your physical device. Okay. This device have one physical address. Physical address is called the MAC address. This device also have one. If I sending frame to switch, so this frame is coming in gig 0 by 1. Based on frame, this frame have source MAC address, destination MAC address. Based on incoming port, the switch learn this travel from that incoming port. This incoming port is connected VPC3, and this MAC address is for VPC3. They just making the entry against gig 0 by 1. What is the MAC address? MAC address of VPC3. And then if I send frame to Swiss to sending maybe different destination, they just track the frame. Every frame have source and destination MAC address. Swiss take this frame, take the source MAC address against the incoming port. That means gig 0 by 2. Swiss just populate the MAC table for interface gig 0 by 1 and gig 0 by 2 and respective MAC addresses. This is called the MAC addresses. If I sending frame PC3 to PC4, so it just match the MAC address. If this MAC address is in their MAC table, they just forwarding the frame one port to another port. If not matching the destination MAC in their MAC table, they broadcast every connected port, excluding or except incoming port. This is the normal behavior of that means you can call when one PC is communicating it with another PC, this is unicast. And when a frame is going every port, this is called the broadcast. So your question is layer to addressing. So this is happen based on basically layer to addressing, and this is the layer to addressing. In some devices, layer to addressing showing 2 digit then separator, 2 digit then separator. Separator will be maybe colon, maybe dash. Different device will use different format. Like I'm sending the packet and see the router run show or resolution. See here the MAC address. See here MAC address. This they use the different format. 2 digit colon 2 digit colon 2 digit. Total is 12 digit. This is called the layer to addressing or MAC address. Layer to addressing and MAC address is same, synonymous one. Gotham, is it clear? Okay, thank you. Frame. Oh, okay. If you just go to OSI model, in OSI model, the if you analyze the um, layer two, that means in OSI model there have 7 layer. There have 7 layer. Layer one is physical layer. Layer two is called data link layer. In data link layer, in data link layer, the data is equal to frame. Data is equal to data packet header is frame. Just you go, this is the first one is this is the packet, and just see the second one, Ethernet. Just see the second one. This is called the frame. In a frame, there have source MAC addresses, there have destination MAC addresses. This is very common. Okay. If you see the details in Ethernet data, you see the destination, you see destination details. Destination details. This is the MAC address, and the MAC address type is this one. And another is a source MAC address. This is the source MAC address information. And the IP communication is IPv4, not the IPv6. So this portion, this portion is called basically layer 2 frame format or layer 2 header information. If I configure any VLAN, virtual local area network, they will show the VLAN ID. And if I use any protocol, STP or other like this protocol, if you see the any spanning tree, you will see in the another option in frame like this one. Okay, in basically this one 800 to 3 Ethernet frame. There is also have the MAC addresses and others information. So if you consider in layer 2, it's called the frame. If you consider in layer 3, that is packet. If you consider in layer 4, that is segment. Apart this layer, like layer 4, layer 5 to 7, this is called the basically data. Basically data. Clear? Okay, perfect. So you all are requested to ask question. If you make question, the session will be very interactive. An interactive session will get better benefit, I guess. Yes, PDU, protocol data unit. Just consider layer 2 perspective. In layer 2 perspective, it's called frame. It's very in a simple manner or simple way. Where is CDP networks? I have finished. Where is CDP networks? Riaz Khan. Hello, Mr. Riaz Khan. Are you hear me? Anyone from CDP networks? I don't know. Calling. Just a minute. Just Okay, so in Wireshark, show details TCP IP model. Oh, yeah. If you see the Wireshark, you can just here. Number one is just a packet. Okay, just a packet. Number one is just a packet. Okay, and this is the time. So you can say this is the data basically.
Hey
Basically,
guys, you can
data.
ask the Q&A query actually. We have 15 minutes for Q&A. If anybody having any query, please ask for Q&A.
Okay, and this is layer two. Second option. This is layer two. That is called the OSI layer. That is layer two. This is the layer one, layer two. This is the layer three, and this is the layer four. Layer one, layer two, layer three, layer four. In layer four, we will cover the protocol. In layer two, cover the addresses. In layer two, cover the layer two addresses. That means MAC addresses. And this is the packet. Basically, this is called the frame because this packet is coming from Swiss. That's why this packet is called the frame. Okay, understand? Gotham? Yes, okay, fine. Mhm. I think if you have no question, we can close. Anyone have any question? Oh, I have one question. Actually, could you make your home lab through the EVNG in your laptop or desktop? I just shared the emails. Is it okay for you, or I totally making the home lab and recording the session and give to you? Which one, guys? Oh, okay, 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 Khan.
You can even, type your questions if you want, if you want, if you're not comfortable speaking, you can type your questions. So even that is permissible. So a trainer will
I
read the
think
in the chat.
Mr. Khan, I think there is no question basically. I will asking in several times,
Okay. Okay.
so you can close. Can I left? Okay, guys. Thanks for joining this fantastic Juniper courses. This course will just grow your knowledge regarding Juniper devices. So thanks again for joining our courses.
All right, guys, we'll close here. Thanks a lot for joining. Okay.
Okay,
Please
okay,
do
okay,
join tomorrow.
okay,
Thank you.
okay. Tomorrow same time, right?
Same time, yeah, same time.
Okay, okay, guys.
In
Okay.
Indian Standard Time tomorrow at 7 p.m.
Uh,
We'll
okay.
upload in YouTube also tomorrow. Same day.
Okay.
Thanks. Bye.
Allah Hafiz. Allah Hafiz.